So for number 2, our parent function is x squared. It's reflected over the x-axis. Look back at what we did here as well as previous stages. If it's reflected over the x-axis, is that vertical or is that horizontal? Say it again. Vertical, yes. So if it's vertical, is that inside or outside? Outside. And that's going to be a negative on the outside. And then translated 7 units to the left, is that horizontal or vertical? Horizontal. So that's inside or outside?
Inside.
And then how would we write something that's 7 units to the left? It is going to be translated, but if we were to write it out, like, would that be plus 7, minus 7?
Oh, plus 7.
Now that we know what these two things are going to be, we can write out this equation. X equals, on the outside we need this negative. On the inside, because we have something inside, we need parentheses. And we're going to add 7. And then there needs to be a square on the outside of that. Do you have questions on that one? For this next one, we're now changing the parent function to absolute value. These words are switched. This should be stretched, and this should be compressed. What's nice about any time it's stretched or compressed, it tells you whether that's vertically or horizontal, so you don't have to guess. So it's stretched vertically by a scale of 4. That means we're going to multiply the outside. It's vertically, so it has to be outside. And our A value is going to be 4. Then we have reflected over the y-axis. Would that be horizontal or vertical?
Oh, vertical.
It's reflecting over the y-axis.
So what they do?
Horizontal, yeah. It's reflecting over the y-axis, but your x values are changing, not your y values. So it'd be horizontal. That would be inside. And we would have a negative x on the inside. Now that we have all of our pieces and we know what they are, we can write our equation. But in this case, because we have absolute value bars, our inside is basically going to be inside of those bars. Whereas the x squared, there was no real inside, which is why we have parentheses. So this one, we don't need parentheses. You can still write it down. We have f of x equals, we need 4 on the outside of this. And then negative x on the inside. And it would be written just like that. If you wanted to put parentheses around the x, you could. But that wouldn't change anything. Or if you wanted to put it around the negative and the x, you could do that, but that wouldn't change anything. What questions do we have on that one? And this last one, it's compressed vertically by a scale of 1/2. So again, vertically is going to be outside. And it tells us what our scale factor is. So our A value is going to be 1/2. Translated up 14 units. Is that inside or outside? Outside, because it's vertical. Right up 14 units. It's going to be vertical. So just like the one where we have translate left, is that plus, is that minus?
Oh,
It's going up. And then plus. So in this case, both of these things are on the outside. Sometimes that happens, sometimes you don't have any inside pieces, or vice versa of that. So our function, we have f of x equals, we have 1/2 on the outside of our absolute value signs. And then on the outside of that, we also have plus 1.
what? How would you know if it has absolute values on the?
It would tell you at the beginning what the parent function is.
Oh.
So look at that.
Okay. Thank you.
So I'm going to give you guys some practice. The first one is done for you. And these are all just using quadratic equations. There are more problems on this than I want you to do. I really just want you to focus on 9 through 13. And then we'll go over those here in about 5 to 10 minutes. So do hold on to this because the bottom part we'll be using for another lesson. But I'm just going to talk through each one. Let me know if you have questions on any of them. So the first one was given to you. The second one should have been y equals or f of x equals. Those are the same thing. X squared minus 6. 11. This was inside, so you should have y equals or f of x equals in parentheses x plus 4 all squared. Remember, there were two things translated 2 units down and reflected across the x-axis, which were both outside things. So y equals or f of x equals negative x squared minus 2.
Negative a in parentheses x is second power.
So your a value is the negative one, so you don't have to put a.
Oh.
And then for 13, translated 3 units to the right would be inside and reflected across the x-axis would be outside. So y equals or f of x equals negative outside of parentheses, x minus 3 in parentheses, and then squared on the outside. Do we have other questions on those? We're going to start on this, but then finish it tomorrow. This is 2 sets of notes, the next 2 sets of notes. I don't think I and the same thing, but it's a little different. Because now we're given graphs and have to find the equation based on different transformations. So we have to be able to see what it did and use those transformations to write the actual equation. If it helps you, draw in the parent function. So if you need to remember what that is, you can grab your calculator. But I'm going to show you a trick to kind of remember that so you don't have to use it every time. So I'm going to draw the parent function on top of a couple of these, but I won't do that for every single one. So for quadratics, because this is a U shape, we would always start at 0, 0. And then when it goes 1 to the right and 1 to the left, it goes up 1. And then when it goes 2 to the left and 2 to the right, it goes up to 4. Your parent function will always have these 5 points. Negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. If you know those, then anytime you have to draw the parent function, you kind of know where it's supposed to be or where it was originally. So comparing this to where it actually is, what happened? Like 2 units. So I'm just going to shorten it and just put left 2. Now this goes back to what we were just doing. Taking those words and writing them in an equation form. Left 2, would that be inside or outside? Inside. And this is a quadratic, or an x squared. So when we write this equation, it'll be y equals, or f of x equals. This would be x plus 2 or minus 2? Plus 2. Yeah, I know. I forgot that you have. I do have this for you for today. You can sit right here, but then we'll do this tomorrow. I'll figure that out tomorrow. What do I do for this? And then I'll explain anything you need. before we move on to the next one, what questions do we have on that? Now we're going to try number 2. And this is not a U shape, it's a V, so this one has to be your absolute value. So being able to recognize which one it is. Right now we're only going to deal with these two, quadratics and absolute value. For your parent function absolute value, it starts at 0, 0. And you can think about your absolute value lines as like slope. The slope for these lines are 1 and -1. So to draw these points, we can go up 1, to the right 1. Do that like 5 times. Because really it'll keep going on and on forever. And then same thing on the other side, so go up 1, left 1. And if we're comparing that original to what's given, what happened? Translated left 2. Kind of same as this one, but it's just a different function. So again, that would still be on the inside. So when we write that, we are not going to have our absolute value signs. F of x equals, on the inside of the absolute value, x. Questions do we have so far on this? Come on. Okay, you can put y and do the same thing. Either or. So if you're able to see what happened from the original, then you're able to write the equation. You just have to know what happened, what that transformation would be, and things like that. Let's try to do this one without me drawing the parent function. For number 3, what type of function is this? Quadratic or absolute value? Absolute value. And think about the parent function. You can look back at this one if you need to. What changed? Flipped. And it translated up. So I'm just going to write those two things. So flip upside down. Not that much better. Okay. And translate it up how many units? Not one. More than that. As it did these two things, now we have to think about, are these inside or outside transformations?
Outside.
Okay. Flip upside down. That's a reflection over the x-axis. So if it's a reflection over the x-axis, is that vertical or horizontal? Vertical. So that means it's inside or outside? Outside. And then somewhere else we can go. So if these are both outside things, we can write our equation. Start off at the left. How would we write something that's been flipped upside down?
Negative.
Negative. And then outside, so it's going to be outside of our absolute value signs. And then how would we write up 5? Plus 5. Questions on that so far? I've not done this for any of these, but whatever equation you come up with, because you know what the graph looks like, you can put this in your calculator and see, does this match up? If it doesn't match up, okay, I did something wrong. Maybe it should have been plus when I put minus or something like that. So some of these are really easy to see and you don't need to check it. But when we start getting into the ones that are like scaled, those I would probably check just to double check. Right. Going with number 4. What type of function is this? Quadratic, right?
Quadratic.
Quadratic. Or if you don't remember that, you can just say it's x squared. And thinking about the parent function, and you can look at this one if you need to, what changed?
Right. 3.
Okay, so right 3 units and up 1 unit. Right would be inside or outside? Inside because it's horizontal. And up would be
Moved up 1.
so they'd be inside or outside?
Go 2. Go 2.
It is 1. Outside, yeah.
The usual.
That's kind of weird. So now that we know those two things, it's going to start off as x equals, how would we write? We have to do the inside part first. Write 3.
X. Minus 3.
X minus 3 is always opposite.
And parentheses.
And then up 1 plus 1 outside of that. That is a 1 at the end. So the better you get with these transformations, the easier it is to see what's happening, what's changing, being able to describe those transformations and then write them. We want to get to 6 and 7. We'll do 5 and then 6. I don't know if we'll have time for 7 today, but if we do have time, we'll continue that. If not, we'll start that one tomorrow. For number 5, compare it with the parent function. Think about it in your mind. What changed? You guys said 2 different things. What did you say? Reflective over the x-axis and small with the x-axis. And to the left, it did something else too.
Would it be up or down? Up and then translate, right? And then on something.
So think about where it was originally. As 0, 0.
Yeah.
So think about where the center is. So it always starts at 0, 0. Even if it flipped, it would still be at 0, 0. So that wouldn't change.
Okay.
Now there are three things. You could have all of the transformation, not all, because it can't stretch and compress at the same time, vertically. Anyway. Reflect over the x-axis. Is that inside or outside? Outside, because it's vertical. Left 2, is that inside or outside? That's
Inside.
because this one's neutral and the last one is outside. But this would be which function? Brayden, I was like, someone just asked me. Okay. So when we start writing this, start off as a x. What would be the first thing we write? So in this one, no, we wouldn't because we have the absolute value. If it was a quadratic, then yes, we would.
Negative. Yeah.
We are going to use the negative first because it reflects and it needs to go on the outside. Absolute value bar. Plus 2 to the left because it's opposite. Minus 1 on the outside. So this would be 1 because there's 3 different things going on. Put it in your calculator, check it. So I'll do that up here. You can do that with me if you want to. If I open up my calculator. So when you put it into your calculator, you can check it via the graph or the table, it doesn't matter. So we said negative absolute value x plus 2 minus 1. Grab it first. That does look like that, but I'm going to look at the table because that would be more precise. So this, we call it a vertex point. The point where it starts is at negative 2, negative 1. Negative 3, negative 2. That matches. Matches, and then going the other way, -1, -2, 0, -8. That is a really good way to check yourself, especially if you're not sure. We're actually going to stop there. So we will continue the rest of these tomorrow, and then you'll have time to practice these tomorrow as well.